Fantastic. This is the International Space Station. Welcome on board.
Thank you, Paolo. You are now connected with the students in Toulouse, Cologne, Frascati, and Lisbon. Please begin the greenhouse event.
Thank you, Melody. Good afternoon, everybody. Guten Tag, Deutschland. Bonjour, la France. Buongiorno, Italia. Boa tarde a Portugal. Welcome on board of this International Space Station for the EPO greenhouse experiment that involves us here in space, but involves you down there, because you guys are going to help us today in trying to figure out something about going in space, exploring, continuing our exploration. We're going to do together something to verify that if we can actually put plants in space, grow things that we can eat, and important to have them germinate, have seeds, and try to reseed them again. This is something that not clear yet, and we want to see how this microgravity environment, radiation environment, and different environment does to these plants. So we have here a mini greenhouse. It's already set up here in a corner, but we will now together work and make sure that the greenhouse, the experiment starts. So I'm going to start by putting on some gloves, because we don't want to contaminate the plants, nor then to contaminate us here in space. You on the ground, when you will do your experiment, you will not need to do this. And then we'll work together. We'll put some water into the chamber and initiate the growth. Okay, this is the setup that we have here. We have a mini chamber containing a growth medium, which is a big term for some sand with some nutrient for plants. We have a bellow that contains the plant, so the plant can be isolated, and if the plants will lose something, it doesn't float around here in space. As you see, everything floats, so you really need to be careful, otherwise you lose everything. Attached to this growth chamber, we have a syringe and a little reservoir with water. So what I'm going to do now, I'm going to take a measured quantity of water, a specified quantity of water from the reservoir, put it into the syringe, and then with this syringe, put the water into the growth medium. I'm going to take about 50 milliliters. The total amount that we'll put there is going to be about 210 milliliters, and you will do the same. So as you see, growing a plant is something simple, but we are not trying to make it complicated by doing all these measurements, but we are trying to make out of this little thing a scientific experiment. And you can do a lot of things, a lot of observation. You can help us if you really look at what you're doing and make sure that you understand what you do and you do it carefully. So let's go ahead and put some water in here. And now carefully I'm pushing the water into the growth chamber. We don't want to go too fast because the water may spill or it may flood the chamber. We want to make sure that we put enough force to get the water in there, but slowly, so the growth medium, the earth, the dirt that is inside there gets wet homogeneously without creating a spot. And here we are about a half of it. And when I'm going to be done here, we'll wait a minute to let the water expand inside, but then we will actually drain the excess water, if there is any, just to make sure that we don't leave water inside floating around. This can cause, especially here in space, some mold, some growth, something inside that we don't want. So we will drain the excess water. So here we go. I'm now complete with the 50 millimeters. I'm going to remove the clean water supply water reservoir and put a wastewater bag on it and then drain the chamber. As you can see, a little bit of water came out, not too much, which means that all the water has been, the vast majority of the water has been absorbed by the growth medium. We also have a measure of how much water is given there, and this is also important to know. So at this point, we can disconnect this system for watering. We will be watering frequently in order to maintain the roots wet, and then we will actually remove and prepare the upper part to let the plant, let the space for the plant to grow. So inside the chamber we have 7 plugs, which correspond to the areas where the seeds have been planted. I'm going to remove those plugs in order to leave the space for the plants grow. Very good. The plugs have been removed. Seeds are now free to grow. We will close the chamber and put it up in our corner, in our little corner that we have set up where there is a light. We have a controlled temperature environment, so we make sure that there is enough light, a good temperature, enough water for the plants to grow, and we will initiate our measurements the same way you will do on Earth, and then we will compare. I will take pictures, video, and you will do the same, and we'll post them and compare our observations. As you can see in our corner there, we have 2 chambers. One has a seed of lettuce, and the other one, the one that we just initiated now, contains Arabidopsis, which is a plant that has a very known genetical build-up, so we can actually know what it's doing, and is very well known, very used in biology. So here is our setup, and so we can declare the experiment initiated. I'm looking forward to the plants grow. Maybe we'll eat some salad here. We have some fresh food here in station. It's not going to be enough for us to actually eat and survive on that, but for the future generation, for the future astronaut going to Mars, going even beyond that, this will be a very important. So all together, today we are doing a very important step, and we are also having fun. So let's go ahead with your questions and see.
Toulouse, your question, please.
Hello, my name is Marius. I have a question. How is oxygen regenerated in the space station?
Marius, bonjour. The oxygen on the space station is generated by breaking down water. We actually have water, and especially wastewater. We have a special equipment here that breaks it down and we discharge the nitrogen, but we keep the oxygen and we breathe it in this way. We have a very interesting system here on station because we have to recycle everything. We cannot throw away stuff, or at least we try to throw away the absolutely minimum, and oxygen is one of the resources that we need to maintain and be careful on how we use.
Cologne, your question, please.
Hello, my name is Clara, and my question is, how does the water get through the plant in the effect of microgravity?
Hey, Sarah, the water, how the water gets to the plant? Well, the water is distributed inside this growth medium, and it gets homogeneously distributed in there. Plants actually have roots, and the roots seek the water. So it's actually the plant looking for the water more than the water looking for the plant. And this is also one aspect that we are actually looking into it, verifying if the fact that there is no more gravity, how this fact changes the way the roots go down on the growth medium and actually looking for water.
Frascati, your question, please.
Hello, my name is Flavia, and my question is, what happens if the astronaut suit is damaged during the external activity from the ISS, and how much time have you got to return safely on board?
First of all, we really make sure that everything outside the station doesn't have any surface or anything that could cut or provide or put us in danger. So this is very well carefully checked and make sure that this doesn't happen. But in case this would happen, it depends on the size of the hole and how much air will actually escape from the suit. We have a special container pressurized tank in our EA spacewalk suits, and in case of an emergency, this tank is actually activated and can provide us for about 30 minutes of additional air to pressurize our suit, and this should be enough for us to rush back to the airlock, close the airlock, and pressurize it again and be safe.
Lisbon, your question, please.
Hello, my name is Simão, and my question is, how many times do you have day and night, and how do you deal with it on the space station?
It's a very interesting question because we use the cycle of the sun and the night, day and night, to actually set ourselves and actually set our working day and our rest time. Well, here on station we are orbiting around the Earth at 28,000 kilometers per hour. That's about 7 kilometers per second, and which means that every hour and a half we actually go around the Earth, and we are for about, I would say, 45 minutes, 50 minutes to an hour on the sun side, but half an hour more or less in the other side of the Earth, which means we are shielded from the sun. So at the end, if you really count it, we have 16 sunsets and 16 sunrises per day, which confuses us. And but of course, we are not looking outside the window all the time. We're actually checking our watch. We use the Greenwich Mean Time, which is the time of London, the universal time, and we go by that, and we make sure that we don't look outside the window if we want to know if it's time to sleep or not, but we check our watch.
Toulouse, we have time for another question. Your second question, please.
Hi, my name is Jenny, and my question is, how do you communicate with your loved ones from the ISS?
Yes, that's obviously it's very important for us to be in touch from the ground, and first we will talk to our mission control center and make sure that we get all the work and they follow us what we are doing. But second, also have a little bit of time off and make sure we talk to our families, friends. We do have here on board the possibility of using what is called an IP phone, which is a kind of internet phone, and we can actually talk when the signal is available, when the link is available. We can actually call essentially any phone on Earth. Also, periodically, about once a week, we have a 10 minutes or 15 minutes slot in which a video conference is set up, and we can actually talk to our families. I talk to my wife, Sasha, and to my daughter, Sophia, and it's very nice to talk to them and make sure that they don't feel too far away.
We have time for one last question. Cologne, your second question, please.
Hello, my name is Patrick, and my question is, how do you pour water on the ISS?
I'm sorry, I missed it. Say it again, please.
My name is Patrick, and my question is, how do you pour water on the ISS?
How do you pour water on the ISS?
If I understand correctly, how do you pour water on the ISS? Well, obviously, here in the ISS you cannot pour water because water doesn't go down. We have these drinks bag that are like our cup. So they are completely closed. The water is inside. They have a special straw with a kind of a tap in there because we need to close it. If we would not close the tap, this is what happens, which means water is going all over the place. And of course, we don't want it to go anywhere. We don't want it to go into the environment and to the equipment, and therefore we keep it contained all the time. It's very interesting, and it's fun to play once in a while.
Paolo, ESA ESTEC, we hear we're near the end of our time. We would like to thank you so much for the greenhouse demonstration today and for taking our questions. If you would say goodbye to the audience, we'd like to say goodbye to you.
Yes, thank you everybody for being up here in space with me and my other fellow astronauts on board on the International Space Station. I'm pretty sure that you, when you grow up, will have the possibility to go in space. Space probably will continue, exploration will continue. Thank you for helping us in following this experiment, doing your observations, comparing them with us, and help all of us in understanding better what happens. So, thank you to everybody. Thank you to everybody for your participation here, and we are looking forward to see you on the internet and see you when I come back. We will do another of this section and compare the results. Ciao.